This video will provide a basic understanding of the roaming feature on the Tsunami Point-to-Multipoint 800 and 8000 units and demonstrate the configuration of the radios to utilize the feature. Please note, the roaming feature is not available on the QuickBridge radios and is not supported under the legacy mode operation. Also, to ensure optimal roaming performance, it is recommended to have a RF site server done professionally along with appropriate RF engineering. So let's go ahead and cover what roaming is. Roaming enables a mobile SU subscriber to provide seamless network services by constantly monitoring the quality of the wireless link with the currently associated BSU and also other BSUs that are part of the network. The SU uses the link quality parameters such as local SNR values and receive modulation rates to calculate the receive SNR for each BSU. If the calculated receive SNR is lower or equal to the configured SNR threshold, the SU roams and will establish a link with another base station. There are three different types of roaming parameters to determine which BSU the SU will link up with. We have slow roaming, fast roaming, and emergency roaming. Emergency roaming is not a configurable parameter. We're going to go ahead and cover these later on in the video. Alright, before we describe the mechanics of roaming, it is important to understand the following terms. Roaming preferred channels. This is a list of channels maintained by a BSU where its neighbor BSUs are operating. Roaming channel list, or RCL. This is a list of channels that are learned from the associated BSU, known as roaming preferred channels, and are not blacklisted locally on the SU. An SU uses this channel list to scan BSUs while roaming. And then we have the usable channel list, or the UCL. This is a list of channels that are available to an SU for the configured frequency domain and are not blacklisted. Slow roaming. When the calculated received SNR for the current link goes lower or equal to the configured slow roam SNR threshold, then the SU starts to slow roam. During the slow roam, the SU scans channels from the roaming channel list, the RCL, one at a time. After scanning a channel, it returns back to the channel where the current BSU operates, resumes data transfer, and then jumps to another channel in the RCL, and so forth until it scans all of the channels. Once the scan is complete, the SU calculates the received SNR for each BSU. It finds the BSU with the highest SNR values. If the BSU is better than the current BSU, then the SU roams to that BSU. Fast roaming. When the calculated received SNR for the current link goes lower or equal to the configured fast roam SNR threshold, then the SU starts fast roaming. During the fast roaming, the SU starts scanning all of the channels in the RCL until it finds a BSU with better receive SNR than the current BSU. Once it finds such BSU, the SU roams to that BSU and does not scan any more channels. Now, if the SU does not find a BSU with a better receive SNR in any of the channels in the RCL list, it resumes operation with the current BSU. Now, if the quality of the link with the current BSU is still such that the fast roaming procedure has to be started again, the SU starts scanning channels from the usable channel list, the UCL, instead of the RCL, until it finds a base station with a better receive SNR. Once the whole list is scanned and no better SU is found, the SU resumes operation with its current BSU. The SU repeats this procedure until either the link quality improves or a BSU with a better receive SNR is found. Emergency roaming. Emergency roaming will only occur on the SU when the wireless link with the current associated BSU is lost for at least 1,000 milliseconds. During emergency roaming, the SU scans all of the channels in the RCL until it finds any BSU. If the whole RCL is scanned and no BSU is found, then the SU starts scanning the channels from the beginning of the UCL list instead of the RCL list. The SU keeps scanning the channels from the UCL until any BSU is found. When a BSU is found, the SU will roam to that BSU. A note, there is a possibility that the new BSU may not be better than the previous BSU in the SNR department. Alright, so let's go ahead and get started. We're going to get started on the base station side configuration. Alright, to go ahead and get into roaming, go to Advanced Configuration. We can click on Wireless Interface 1 and then Roaming. Alright, by default, roaming is disabled. Alright, so go ahead and select Enable and click OK. And this is going to open us this screen right here. Alright, so let's go ahead and cover some of these options right now. Roaming status we discovered, it's either enable or disable. You have the link profile. Now the link profile itself enables you to configure a roaming link for a roaming enabled SU. When this link is enabled on the BSU, you're going to select the profile, configure to this particular subscriber, okay, and now you'll be able to set little sort of things, different SNR values and things like that, okay. Next one down is announcement period. When roaming is enabled on the base station, the BSU sends announcement messages on every configured announcement period. This period can be configured in a range from about 25 to 100 milliseconds. Default is 25. When roaming is disabled on the base station, the announcement period is set to 150 milliseconds. Right there, a note. Reducing the announcement period improves the roaming time and may result in lower throughput. So that's definitely something to consider. All right, then we have the max packet per burst. When roaming is enabled on the base station, then max the number of messages that can be sent in a burst can be configured in the range of 1 to 16. When roaming is disabled on the BSU, the maximum packet per burst is set to 4. After you have done with everything on this side, just go ahead and click OK. A quick note about the max packet per burst. Reducing the number of messages per burst improves the roaming time and may result in lower throughput. If the maximum packet per burst configured in QoS is greater than this value, then this parameter supersedes. Now the last option is the roaming preferred channel. Now each BSU on the network maintains a list of channels with their neighboring BSUs. When roaming is enabled, the SU learns from this channel, all right, and it will use the roaming channel list, the RCL, to reduce scanning time while searching for BSU with a better receive SNR. So basically what you want to do here is, let's just say we have 3 base stations, including the one we are right now. You're going to add the channel of the other 2 base stations in here. You're going to go to the second base station and you're going to add this one and the other one. You're not adding the channel that it's currently on. So you just select the channel and click add, and then so forth and so on. You know, maximum of 5 entries. So when the subscriber connects, it's going to look at the RCL list and it says, okay, I'm on this channel. It's going to scan the other 2 channels to see if they're cleaner, if the SNR is within values. And after you're done, go ahead and click OK and commit. And the base station is done. All right, so let's go ahead and look at the SU side now. All right, to enable roaming, exact same thing as on the base. Advanced Wireless Interface 1 and then roaming, roaming status, enable, and click OK. You can see here there's some different options. We're going to go over them. All right, so we still have our roaming status. Now, roaming link profile. Now, the profile itself is the same profile linked for link profile up here. So just click edit over here, so you'll be able to kind of create little things that you want the radio to do. Either you want it to be DDRS or not. Maybe you want to have it set to a static TX rate, receive rate, your data streams, and things like that. So you could have each satellite could have its own profile, where the base you could have one profile or many profiles associated to it, but on the satellite you can have, if you have multiple satellites, you could go ahead and just create these multiple profiles. Once they're done, click OK, and then you're going to be able to see them over here, and then they will show up over here. When you pull them down, you have whatever profiles you have. Okay, now this is what we covered before. Here's your slow roam, your fast roam, and your SNR toggle offset. Okay, one of the things I do have to mention is for the slow roam and the fast roam, this is one of those settings that you're going to have to play around with. You're going to have to make sure that you know what your SNR is like going into the link. So if you have 2-3 links or something like that, you would have to know what the SNR is going when you attach to a specific base station. When you have two base stations intersecting, what the SNR is there. So basically, when you want it to cut off to do a slow roam or to do a fast roam. Okay. So once again, we already covered the slow roam and the fast roam. Right. The slow roam, when the link goes lower or equal to the configured receive slow roam SNR threshold, then the SU starts slow roaming. The default threshold is 0, and it's between 0 and 127. Now for the fast roam, we have when it's calculated, the receive SNR for the current link goes lower or equal to the configured receive fast roam SNR threshold, then it's going to start fast roaming. Okay, once again, it is between 0 and 127. All right, so the last option is the SNR toggle offset. This offset is used to avoid frequent roaming, like a ping-pong effect, in situations where the current BSUs receive SNR and the new BSUs receive SNR very close. Now, if the current BSU SNR receive SNR value plus the SNR toggle offset is less than the new BSU receive SNR, then the SU shifts to the new BSU. Else continues with the same BSU. To configure, enter desired offset ranging from 0 to 10. 10 would have a greater bearing on how you wanted to use this feature. All right, a few items to know about the slow and fast roaming. The slow roaming threshold should be higher than the fast roaming threshold. Otherwise, the slow roaming procedure will never be started. Switching from slow to fast and from fast to emergency roaming is possible, but vice versa is not. In the roaming deployments, it is recommended to configure the same announcement period on all of the base stations. While working on DFS channels, the roaming time increases and affect the performance as device scans the channels for the presence of radar for duration of the configured channel wait time. In VLAN aware scenarios, it is recommended not to use roaming. The roaming time for an SU increases when the radius space authentication is enabled on the BSU, and when SU registers with a new BSU, it will transfer all of the data buffer during transition to the new BSU. Okay, so let's go ahead and look at a demonstration of how roaming actually works. Okay, so what I have here is we got two base stations. One is on channel 149, the other one's on channel 165, and we have a boat, a ferry, or whatever, and it's going to be roaming from base station to base station. Okay, so as we discussed, the roaming preferred channel list within the base stations, this is going to be basically the first place where you're going to start. So in this base station over here, okay, you're going to add channel 165, okay? And then in this base station, you're going to add channel 149. Okay, now these two know that they're aware of each other, but most importantly is that as this boat comes across, it's going to know what channels to use and what channels to scan for. It's not going to start scanning for any other channels because it's not aware of any other channels. So it's definitely important to make sure that you do your RF engineering first to make sure that you got clean RF environment for each channel location. Okay. Now, to the slow and the fast scan, this is where it kind of becomes tricky, because when you kind of take like a scenario over here where the ship is between two base stations. Okay, so somewhere around here, so to speak, you're going to have a, where they're going to meet. The signals are going to meet. Okay, they're going to overlap. So what's going to happen is, depending on how far it is and what the SNR value is going to be, that's where you want to configure your slow and fast scan. Okay, because you don't want it to drop too much too fast. Okay, because if you can have video, internet, or anything like that, you're gonna force it to switch over to this base station a lot sooner than it needs to with a lower SNR, even though this one still has a fairly decent SNR. Okay, so this is a trial by fire type thing where you're gonna have to know what your SNR is, and be honest with you, at any given point. And if you have, it's going to keep on going, you're going to keep on adding them. So the one thing to remember is it has to see it, right? So meaning that if this ship is over here, okay, and then you still see channel 165 all the way over here, that means that it still sees it. So that means that if you have another base station over here and it still sees channel 165, you are going to have to add it to its roaming preferred channel list. Okay. Once again, it's a trial by fire type thing, but if you need any help, Proxim Technical Support is here to assist you. To learn more about Proxim Wireless and our solutions, please visit us at proxim.com or follow us at Twitter @Proxim.